Hi, everyone. Thank you for joining this evening, morning session, depending on where you are, I suppose, and whether you're joining now or watching the recording after. Glad you're here. So today we're going to give an overview of some of the tools that will be useful for your hackathon projects. We're also excited to have someone from Red Hat here to demo the OS Climate ETL pipeline. Now, this could be particularly relevant if you're working on the climate risk challenge or anything that might involve climate data, right? So, Jay, I'm not sure if you're ready on your side.
Yeah, I'm ready.
Good stuff. So I'll pass it over to you, Jay, and take the floor as
Sure.
you please.
Let me share my screen. Are you able to see my screen?
Yeah, I can see it.
Okay, so I put together the pipeline demo using data mesh architecture. The data mesh architecture is managed the data platform for any data science or AML project. Data mesh architecture is based on four principles. The first principle is domain ownership. Each domain owner own the platform. What that means, traditional data warehouse or a data platform managed centralized, right? It's centrally managed. But data mesh architecture, in contrast to that, it's decentralized platform. The reason every domain owner knows the domain well, so they know how to secure the data. They know how to manage the data instead of managing someone who doesn't know that their data. Right? That's the purpose. The domain ownership take care of their data. Then the data platform acts as a data product. Each data platform, and expose data as a service. That's data as a product. Third principle, self-serve infrastructure. Each domain owns their own infrastructure so that they don't need to depend on centralized infrastructure team to manage your data platform. And the fourth principle is federated governance. So since domain owner knows the data, they know how to apply the governance, so they can easily apply the governance and data security. These are the four principles followed by the data mesh architecture. As part of the hackathon, Lucas asked me to build a simple a demo so that the audience can run this demo on their local laptop. You don't need to have big infrastructure, but you can running as a Docker Compose on their laptop. So this hackathon demo consists of many components. Part of the data mesh implementation, Airflow. You can see here, Airflow. I put every instruction on the README file. So you can go through the README file once you download this Git repo. Everything's available in the Git repo. You can go through this README file for the instruction, how to run it, how to go to different tool, see the pipeline, how the pipeline executing it. So when the pipeline completed, you can go to a different tool set to view the data. Data science people may not be technically strong enough to run through a different tool, but based on their interest, based on the tool they are flexible, they can use Jupyter Notebook for analyzing the data, what pipeline injects the data into the data platform. If you're a technical person, you can run Jupyter Notebook. If you're a business person, you can go to the dashboard. I provide the data superset. Superset is just a dashboard. The analytics team or data scientists, they can go and visualize the data, what pipeline produced as part of this hackathon. That been IO. So we use for data injection as part of the pipeline. Airflow is the pipeline tool where you can define your pipeline. What's your source of data and what's the destination? What transformation need to apply to the your transformation your input source. That's a part of the pipeline which is deployed into Airflow component. Airflow is kind of pipeline tool. You can schedule it, or you can also connect it to the real-time streaming engine, whether Kafka, any streaming platform. You can collect the real-time data apply the transformation, and push into the destination. The destination could be database or any storage. So as part of this hackathon, we built the S3 packet, not S3 packet, S3 compliance framework, which is Minaivo. You can use any S3 compliance storage. It could be AWS or Google storage. But as part of this demo, we are using open source tool, which is called Minaivo. Okay. For data injection, how do you the pipeline push the data back to the storage using Iceberg framework? Iceberg came from Netflix. Netflix won the Iceberg, then they released as an open source. The Iceberg persists the data, huge volume of data. Persisting analytics, machine learning data in transactional database is very hard. It's hard to manage. In Iceberg, it persists the data into S3 packet in an optimized way. And also for fetching the data from S3 packet, we use Trino. Trino is a data federation engine, means it's a query engine. It can connect to multiple data sources. It could be database, it could be S3 packet, it could be a file system, or it could be Kafka. You can connect to the data source and then create the data view for analytical purpose. So these are the components part of the data mesh architecture. We use Hive for a catalog. Catalog means you mapping storing data into different table format in S3 packet, but reading data from a file system is very hard. So we need to have some catalog. So the catalog have the structure of your data, how is stored in the file system. Okay, that's Hive Metastore. Hive Metastore is a catalog for getting the data from the file system or any S3 packet. Okay. Let me show you. So I'm running already my data canvas. I put all these components as a Docker compose. Each component has a one Docker image. Pulling those Docker image from Docker Hub or any other repositories, it takes a lot of time because it's a lot of images. We have around 10 to 15 components. Getting it from remote repository is taking a little bit of time, or you have to have a proper internet connection. To avoid that, what I did, I pull all the images and create a tar file. That way, you can just run the tar file on your laptop without connecting to the internet. Okay. So I wrote these are the components I perspective here. This is a Docker compose. This is where I have all the components deployed. Each component is a service, and each component has a Docker image. So using this Docker compose, I build the jar. I have multiple script. Save Docker images means it pulls from online and keep it in locally. So then, if anyone wants to run this compose, you can just run the save Docker image and pull all the image locally. You don't need to connect to the online after that. Then you can use load Docker image before starting the Docker compose, right? So the load Docker image compose is load the images on your local and deploys as part of the Docker compose. When you run the Docker compose, you can just specify Docker compose up or no build. That way, it will not pull from internet. It just take the images from your local laptop, the one before you build it, and run the whole Docker compose. Let me run it. So it's going to learn all these components, all six. These are 7 components. Then I walk through the pipeline. So as part of this hackathon demo, Lucas gave me this one of the use case, which is from Fannie Mae data. Fannie Mae is one of the U.S. Mortgage federal government mortgage company bank. So we got the data from Fannie Mae and created some certain business rule, apply the business rule to that incoming Fannie Mae data, single home mortgage loan data, and extracts the data only specific field what required for the analytics or your business use case. You can go to Airflow tags. This is a pipeline. The pipeline is written in Python program. So we define all the input, what are the required fields to extract from the input file, and what are the transformation you need to apply. So these are the transformation. So I need to get those fields from the input file in convert into date format, because what data coming from the input source is a text format. So we need to convert into date format, then apply some of the transformation, like a channel map, the value coming as R, and we need to change it to the meaningful value. So that's why these are the meaningful value for some of the fields. These are the business rules. So the pipeline just read the input file, apply the business transformation, then persist the data, the transformed clean data into the S3 packet using Iceberg and Trino. The inject data done. Then using the Jupyter Notebook database data superset, you can visualize the data in the web UI. Okay, I think now all of them running. Then also I have the data lineage component. So if your pipeline has multiple steps involved, each steps might be modifying the data from different data source. So you need to know where the data get modified. That things information you can see it in the data lineage tool, which is Marcus. Okay, I think it's everything running. So I can show that when you run everything successfully, you can see it here, Docker Compose, the Docker desktop, you can see all of them running it. So I want to go and run my pipeline, which is deployed into Airflow. I can see Airflow web server. I can click on this one. So I already pre-filled the user ID password, but in the instruction also, I specified all this information, each component and the corresponding password. Some of the component may not be required user ID password, so you don't need to enter anything. Okay. Let me walk through the pipeline. Pipeline deployed into Airflow. Airflow is a data pipeline framework. It's also a scheduler. You can define a pipeline. You can schedule it what time you want to execute it. Okay? And or you can manually go and trigger your pipeline. So this is a pipeline, single family pipeline. So I disable it. That I don't want to run it all the time. And also I can schedule what time you want to run it. Right? Because it also has a built-in scheduler. So let me go to my pipeline. If you want to see the pipeline here, you can see the graphical representation, right? You can also look at your source code. Each steps, what are the code on each steps? You can go and look at the code for the one. You can also go and change the code here, okay? So right now for simple one, so transform, upload and transform, and insert into Iceberg. This is a simple step. So when you run it, if something goes wrong, if you have any trace on your pipeline, it's a Python code, you can go and check your log. You can see all the log. Let me run this pipeline. It's already run it, but I can run it one more time. Go and click the corner, run. You can just run the tag. It's going to run it. So first step, this is the first step, is running it. It's completed. You can go and see the graph. It means green. Dark green means completed. It's now light green. Second step is running. You can also go and see the log, what's going on. So since it's a lot of data, so if you look at the there is huge data. I put the input file on here also. Data folder. This is the file. Is transferring the data. Still is doing it because I put the batch, run each 100 as a separate batch. That's why you can see here 100 records processed, 100 records processed. It'll take 3 seconds. Yes, done. So now it's completely done. You can go to see the graph. See both of them are completed. Both of them completed. If you have an error, you can see red dot park. You can go and see what was error in the log file and go and fix it. Okay. So this is a Airflow is a data pipeline framework, which you can define your data pipeline and you can schedule it as you can run as a batch or on demand or real time. Okay. So now, so we got the data injection completed, or pipeline completed the data injection. Now, how do you visualize the data? Okay. So I have a different tool for visualizing the data, what we injected through the pipeline. One of them is Jupyter Notebook. If a data scientist, they are comfortable or familiar with the Jupyter Notebook, they can use the Jupyter Notebook, which is already deployed. Okay, this is I wrote a simple notebook code. This Jupyter Notebook uses a Trino. Trino is, as I said, is a data federation query engine. It can connect to multiple data source and pull the data, and it creates a view and provide the data as an outcome. So Trino is also running it. You can go look at how the Trino works. Trino also provide the web UI who are connecting to Trino and coding and fetching the data. What are the SQL you are using to get the data? You can see it from Trino web console. Each query, how long the query is getting to get fetch the data from the data sources. Yeah. Yeah, this is not the one. This is a tuple superset. I clicked the wrong one. Yeah. In see the data. So through Airflow pipeline, it injects the data into the S3 packet, which is Minaivo. I can show you the Minaivo also. Where the data is stored. You can see the Minaivo is on 9,000 port. Usually is Minaivo admin. So this is where all the single family loan data. So just now I fetched the data. So all the data persisted in the S3 packet. Minaivo's S3 compliant storage. You can use any S3, not necessarily Minaivo, because Minaivo is free. That's why we are using for the demo. But you can connect to AWS S3 or Google Cloud Storage, Azure, what are the cloud-based storage you want to use it. You don't need to change the code. Just specify the corresponding S3 packet URL. That's all, and the user ID password. That's all you need it. Changing different storage. Okay, so that's where data stored. So we are seeing all the data injection. So now we are going to fetching the data using the notebook, Jupyter notebook. Most of the data scientists, they love the Jupyter notebook because they can visualize the data and different perspective, different graphical notation. So I'm going to show you here what are the, so these are the connected to Trino, and then once Trino is connected, you can apply standard. So Trino engine is supports standard ANSYS SQL format. So you can write your database SQL to query the data from S3 packet through Hive catalog. Okay, so I'm getting these are the field I'm extracted from the source. Then these are the data. So remember, we apply the transformation. R means retail, R means refine cash. These are the transformation rule. The data comes with the abbreviation or D something, so to transform into corresponding meaningful value. So that's the business rule. Okay. So now we're using the Jupyter notebook, we are selecting data in different format. This for more of data scientists who understand how to use a Jupyter. If it's a business analytics, may not be familiar with the Jupyter notebook, but they might be using some web framework to visualize data. So as part of this demo, I'm using Superset. Superset is one of the open source dashboard web UI. Admin. So Superset also support different data source connectivity. It supports Trino, it supports standard or relational database or NoSQL database. It supports all kind of data storage framework. Since we are using Trino for data injection, since data stored in by S3 packet, we can use the Trino to fetch the data through Superset. But before that, you need to connect to Trino through data set. First thing, you need to create a database connection. As I said before, you can connect any data source. It could be relational database, or it could be Trino or any query engine. There are a lot of query engine available, similar to the Trino. Trino came from, I think Trino came from, Iceberg came from Netflix. Trino came from Facebook. It's the Facebook built for their own purpose, but then released as an open source. So when you create a database, you can create a new database. Then you can select what are the database you want to connect to it to. I can already have that data source connector, which is Trino. When you say Trino, you can go and give the URL. The URL is going to be the Trino URL. Like I say, Trino. There's a format. Trino : / this endpoint for the Trino backend engine. So already connected. I can also view it. This is a connection. Trino admin Trino at 80 iceberg. Iceberg is my catalog, because Trino use the catalog to fetch the data from S3 packet, because you need to have a catalog to get the data from S3, because S3 is a file system. You can't just query it, right? So Trino use the catalog to interpret a SQL language and send to the S3 packet and fetch data and displays as a standard regular format. Okay, so that's I got the connection for the tree now. So now I can go and create a data set, which is already I have already created. I can show you that created here. So I created data sets, and it shows, I can show new one. Let me see chart. I can create a new chart. Here you need a, for a chart, you need a data set. I can create a new data set. It shows what are the data sets you connected to here. What are the data sets connected to here? Data source connected to here. And you can select, then it shows all the table. Well, the was connection disconnected from the Trino. So once you have the Trino connection established, you can go and create a data set, and then it contains the chart, and it shows what are the field stored in the backend S3 packet. It shows all the table structure. You can create, you can choose what kind of chart you want to display your data, and choose the chart. Then it displays all the fields that are fields. Then you can just select what format you want displayed here. So this one, so we have all the banks. This kind of format, it shows seller name and load identifier, and you can see the complete graph, and you can also see the bottom in row-wise data. So this is more of a business folks, analytics. They're not familiar with the Jupyter Notebook. They can use a superset to visualize the data, and they can create a different chart, different view perspective, different view. So what we covered here, we got the README file. I have everything on the README file. So we have a component, Airflow for pipeline, Jupyter Notebook for just analyzing the data, what pipeline persisted in the backend, and Superset for dashboard, web UI based the Superset. In IO, you can see how the data get persisted, how the data get fetched using Trino framework. That's the Trino. And okay, I didn't show there Marcus. Marcus is more of a data lineage. It gives more audit on how the pipeline executed, which is, I didn't show that. Let me show you that Marcus. Host 3000. Yeah, so it shows the pipeline, single family pipeline, what time executed, say it was failed, that's why it's saying failed, now it's completed, it gives all this information. So this is data lineage, where the data get modified, what's the source, when it is completed, it gives all the information as part of the Marcus dashboard. Okay. That way they can see how many of them failed today, how many of them success. You don't need to go to check the Airflow. So business or SRE team, they can come and see it from the Marcus data lineage. When get executed, what's the data source, what's the destination, what's the source. Yep, that's all. So we completed end to end.
Yeah, exactly. So I'm happy your demo got a happy ending in the end, right?